Welcome to The Explainer. Today we're going on an absolutely mind-bending journey. We're talking a massive cosmic zoom, from the deepest, most unfathomable edges of outer space, straight down into the bizarre, invisible quantum realm. We're piecing this all together based on some phenomenal insights from astrophysicist and former NASA executive Michelle Thaller from her recent sit-down on the Joe Rogan Experience. So buckle up, because we're about to completely upend how you look at reality.
It's a colossal question, right? What actually happens when you zoom from the very edge of the observable universe all the way down into the microscopic building blocks of everything? Well, the short answer is everything you think makes sense about the physical world, it pretty much goes right out the window. You know, our human brains evolved to navigate things in meters and kilometers, but today we're pushing way past that comfort zone, and our everyday intuition is about to get seriously challenged.
Okay, let's dive right into this. Section 1, the immensity of space. Let's look at the macro view.
I want you to hold this number in your head for a second. Hundreds of billions. It's so massively huge, it almost loses its meaning, doesn't it? But it is literally the defining metric of our cosmic neighborhood. Our home, the Milky Way galaxy, holds hundreds of billions of stars. And if you peer past our galaxy out into the observable universe, there are hundreds of billions of other galaxies scattered out there. It's just an almost paralyzing scale to think about.
To actually wrap our heads around that number, Michelle Thaller uses this brilliant analogy. Imagine our sun, which, by the way, is huge enough to fit 1,000,000 Earths inside it, shrink that down to the size of a tiny little printed period at the end of a sentence. Even if the sun was just that tiny dot on a page, the Milky Way galaxy on that exact same scale would still be the size of the entire Earth. That's how insanely vast our single galaxy is. We are quite literally a speck on a speck.
But here is the really incredible part. Despite our tiny size, human ingenuity has built tools to actually see across all that vastness. Take the James Webb Space Telescope. As it peers deeper into space, and therefore further back in time, it keeps finding these massive surprises, like these mysterious little red dots. They appear to be these early, supermassive black holes and rapidly growing galaxies that formed way, way earlier than scientists ever thought possible. It completely challenges all those old models of slow cosmic evolution. It turns out, every time we build a better instrument, the universe doesn't just hand us the final answers. It gives us entirely new mysteries.
Which brings us to Section 2, Monsters of the Cosmos. We're looking at extreme gravity here.
You really can't talk about cosmic monsters without talking about black holes. So the crucial point is, they aren't just these random roaming cosmic vacuum cleaners sucking up the whole universe. As Thaller points out, if our sun somehow magically turned into a black hole of the exact same mass, the Earth wouldn't get sucked in. We'd just keep orbiting safely, just, in the dark. The real mystery is the event horizon. That's the boundary where gravity gets so extreme that absolutely nothing, not even light, can escape. We understand the gravity around it, but what actually happens inside? That's still one of the greatest unsolved puzzles in science.
But what about when a massive star collapses but isn't quite heavy enough to become a black hole? Well, you get a neutron star. This is literally matter pushed to its absolute breaking point. Picture a star heavier than our entire sun, completely crushed down into a sphere, maybe just a couple dozen kilometers wide. The density is just staggering. To put it in perspective, if you took just one single teaspoon of neutron star material and somehow brought it to Earth, it would weigh billions of tons. These things act as natural laboratories for studying physics under pressures we could never, ever recreate here on Earth.
And studying these behemoths reveals something even wilder about reality. Space isn't just an empty stage where stuff happens. Einstein showed us that space and time are actually woven together into this flexible fabric called space-time. Massive objects like neutron stars and black holes literally bend and warp that fabric. And that bending, that's what we physically feel as gravity. It means light actually bends around massive objects, and time itself physically slows down near intense gravitational fields. Our everyday intuition screams that time and space are fixed, but the cosmos proves reality is incredibly flexible and far stranger than we feel.
Okay, let's leave that immense gravity behind and zoom all the way in. Section 3, the quantum realm and its microscopic mysteries. Quantum physics governs how the very tiniest particles behave, and let me tell you, it is weird. It's so weird, in fact, that it deeply unsettled some of history's absolute greatest minds. When Albert Einstein first bumped up against certain quantum behaviors, he famously dismissed them as spooky action at a distance. He just couldn't accept that the bedrock of reality could operate like that. That spooky action Einstein was talking about? That's quantum entanglement. And this brilliantly illustrates just how wild the microscopic universe really is. Basically, when two particles become entangled, they act as one single interconnected system. If you change the state of one particle, the other one changes instantly, even if they're literally light years apart. No way, right? But yes. For decades, scientists argued over this, but modern experiments have proven it is absolutely real. At its core, reality is far more interconnected than classical physics ever imagined.
And the crazy thing is, we're actually learning to harness this bizarre interconnectedness. When you compare traditional bits to quantum states, the leap is mind-blowing. A complex problem that might take a traditional supercomputer literally billions of years to crank through, a quantum computer could potentially crack that in mere minutes or hours. It's an absolute game-changer for humanity's future that could completely revolutionize medicine, cryptography, and artificial intelligence.
Let's move to our next stop and see how this builds into the biggest picture of all. Section 4, Echoes of the Big Bang, the origin story. So how do we actually know how it all started? Well, one of the best pieces of evidence for the Big Bang is the cosmic microwave background, or CMB. Think of the CMB as the literal afterglow of the Big Bang. It's this ancient radiation that just fills the universe in every single direction. Using super-sensitive instruments, scientists can map these tiny microscopic temperature variations in that radiation. It's basically an ancient cosmic fingerprint that shows us exactly how the very first matter clumped together to eventually form every star and galaxy we see today.
But looking all the way back to the beginning inevitably forces us to ask the ultimate question: what happened before the Big Bang?
The honest, scientific truth? We really don't know. As Michelle Thaller emphasizes, being upfront about our uncertainty is a core tenet of science. When we rewind back to that initial singularity, our current models just sort of break down. But we do have hypotheses. Some researchers think we might live in a cyclic universe, just an endless loop of expansions and contractions. Others think everything just popped out of quantum fluctuations. And some argue that time itself literally began at the Big Bang, meaning asking what happened before it is like asking what's north of the North Pole. It just doesn't mean anything. We might not have the final answer yet, but that's not a weakness. That's exactly the fuel that drives continuous scientific exploration.
Which brings us to our final takeaway. Section 5, Our Place in the Cosmos, the Human Perspective.
Look, physically speaking, we are incredibly insignificant. Human civilization occupies an infinitesimally tiny slice of this unimaginably massive universe. But think about what our minds can do. The exact same human brain that evolved just to, find food and survive in local environments measured in meters can now mathematically comprehend distances billions of light years away. We've mapped out galaxies, we've photographed black holes, we've detected invisible ancient radiation. Our physical footprint might be tiny, but our cognitive immensity, it's just staggering.
Ultimately, I think the most empowering takeaway here is this: we aren't separate from the universe. We are made of the exact same star stuff as those distant galaxies. The universe evolved over billions of years, and in this one tiny little corner, it actually produced creatures capable of looking back out and understanding parts of itself. Literally, we are the cosmos trying to figure out its own mysteries.
As we've seen today, every single time we build a new telescope or run a new quantum experiment, reality turns out to be way stranger and more fascinating than we ever guessed. Science doesn't claim to have all the answers. It just gives us the tools to keep exploring the unknown. So I'll leave you with this. If the universe is an ever-expanding puzzle, and we're just at the very beginning of understanding it, what are we going to discover next about our own cosmic significance? Keep asking those big questions, keep looking up, and stay curious. Thanks for joining me on this explainer.